Hello and welcome to my channel. Prometheus operator has become de facto standard for deploying and managing Prometheus instances in Kubernetes. When you're just getting started, it may be confusing to wrap your head around of all of those labels that you need to apply to monitor your applications. In this video, I want to clarify configurations and give you enough examples that you can use in your own work. First of all, why would you even want to use Prometheus operator? The main reason is that it can help you to create and discover targets in Kubernetes. For example, ServiceMonitor object is automatically converted by the Prometheus operator to native Prometheus configuration. Now, to be crystal clear, you can create this Prometheus config on your own, and it will work in the same way as the ServiceMonitor object. But you can see that it's much larger and easier to make mistakes. Also, when you create a ServiceMonitor object or PodMonitor, Prometheus operator not only converts it to Prometheus config, but also reloads Prometheus without restarting and causing downtime. Besides that, Prometheus custom resource provided by the operator also allows you to configure Prometheus specific parameters such as retention, global scrape interval, and others. And of course, Prometheus operator will manage lifecycle of the Prometheus and Alertmanager on your behalf. You can find the source code in my GitHub repo. In this video, we'll use AWS, but all examples with slight modifications can be applied in all public clouds. First, we'll create VPC and EKS cluster from scratch using Terraform. Then deploy Prometheus operator and Prometheus itself. In the first example, I'll show you how to use PodMonitor object and the difference with the ServiceMonitor. In the second example, we'll replace PodMonitor with ServiceMonitor object. Then deploy Grafana and create a simple dashboard based on the metrics provided by our application. Next, I'll show you how to add additional scrape config to the Prometheus and monitor targets outside of Kubernetes. Then we'll talk about probe, custom resource, and how to use it with black box exporter and monitor a website. Finally, we'll configure Alertmanager to send alerts to the Slack channel. In case you want to follow along, you can use my Terraform code to create AWS VPC and EKS from scratch. When you're just learning, you should not use Terraform modules or blueprints. It creates even more confusion. Use plain Terraform resources instead. Here we have EKS cluster, and we also need to enable CSI driver add-on to deploy stateful applications such as Prometheus. To use Terraform, first you need to initialize the state and download modules. Then run the plan or apply to create all the components. It may take up to 20 minutes to create VPC, EKS, and node groups. To connect to the Kubernetes cluster, you need to update your local configuration by running EKS update kubeconfig command. Then simply check if you can access the cluster. You can run kubectl get services or nodes. Prometheus operator has a very nice documentation and examples that you can use. But first, you need to select a specific version that you want to use. You can find custom resources that you need to create before you deploy the operator and other components from the example folder. Don't use Helm when you're just getting started to deploy Prometheus operator. First of all, let's create a dedicated monitoring namespace where we will deploy all our monitoring components. This label monitoring equal to Prometheus is important. It is used by the operator to select objects such as service monitors and pod monitors. You'll see later a few examples of how it is used. I think it's the most confusing part of the Prometheus operator when you create something like service monitor and it's not showing up in the Prometheus UI. After you go through this tutorial, you'll be able to debug and quickly find the issues. You can apply all the stuff from the folder at the same time, but I want to do it step by step. It's easier to understand. Let's apply the namespace. Next are the custom resource definitions for the operator. We need to create all of them. I prefer to use Kubernetes secrets instead of Alertmanager config resource. You can use either create command or push and use server-side apply. If you try to apply it on the client side, you may get an error that the annotations are too big. In that case, just use create instead. Now, let's list all the CRUDs. The next step is to create airbag policies for CRUDs. There are view and edit roles. Let's go ahead and apply them as well. The last step in deploying operator is the deployment itself. We need a dedicated service account, cluster role to get access to all those CRUDs in all namespaces. Then bind the service account for the operator with the cluster role and the simple deployment object. On line 28, it creates a kubelet service that is useful for monitoring persistent volumes as an example. Let's apply the deployment. Let's get pods and make sure that operator is up and running. In case you made a mistake and maybe didn't bind the service account to the role. It happens when you use a custom namespace and not monitoring. You should check operator logs for any errors. This one looks clean. We can continue and deploy Prometheus. Create a service account. Later in this video, we'll grant additional permissions to Prometheus to AWS API. It also needs a cluster role to discover targets. Bind cluster role with the service account. Update the namespace if you used a different name. Finally, the Prometheus custom resource itself. You can use default version of the Prometheus or specify the one you want to deploy. Then PodMonitor name selector. It selects the namespace based on the attached labels. In our case, it's monitoring equal to Prometheus. It means for now we can only create PodMonitor objects in the monitoring namespace. The second part is PodMonitor selector. Each PodMonitor object should have Prometheus equal to main label in order to show up in the targets. Then we have pretty standard resources block and storage. You can also add affinity and anti-affinity here. Another important part that you can configure is retention. The default value is 7 days, I think. You can find all the parameters under the documentation in the official Prometheus operator repo. Let's go ahead and create Prometheus. It may take up to a minute for Prometheus to allocate persistent volume and become ready. I would also suggest that you check logs in case you misconfigured something and Prometheus is not able to get access to Kubernetes API or something else. Prometheus operator will also create a service that you can use in the ingress or just port forward it to the local host. Go to localhost 9090 to get access to Prometheus UI. At this point, configuration should be more or less empty, just some global parameters without any targets. If you switch to the target section, it should also be empty. To test Prometheus, I created a simple Golang app to generate some fake metrics. I use Prometheus Golang library to expose a summary of the duration of the requests. There is an infinite loop that records metrics with a random sleep interval. We also have a /fake path and status code 200 as additional labels on that metric. For the app, we'll create a staging namespace with a monitoring equal to Prometheus label as well. It's optional. You can still create PodMonitor and ServiceMonitor objects in the monitoring namespace. You'll still be able to monitor your application. I prefer to deploy PodMonitors and ServiceMonitors to the same namespace along with deployments and services. If you want to do the same, you need this label. This is a public image that I pushed to the Docker Hub, so you can also use it for the test. The first object that we'll create is the PodMonitor. For that, you need to explicitly expose the port and give it a name, such as HTTP metrics. For this demo, you don't need a service, since we're not going to expose this app, but later it will be useful to show the difference when we create a service monitor. This service doesn't expose metrics port, it's important. Finally, the PodMonitor object. We'll create it in the staging namespace. This label Prometheus equal to main must match the one that we used on the Prometheus object. If you omit this label or define a different one, it will not be discovered by the Prometheus and will not be converted to Prometheus target configuration. In this case, namespace selector is optional since we create this PodMonitor in the same staging namespace where we have the app. In case you create this PodMonitor in the monitoring namespace, this must be defined. Then selector. In this object, the selector should match the pod labels. When we created deployment, we used this label app equal to my app. Under endpoints, you need to specify the port by using the name that you gave on the deployment object. In this case, it's HTTP metrics. The path is optional in this case because it's already default. Now we can apply it. Make sure that the app is running. Check if the PodMonitor object was created in the staging namespace. If you go to Prometheus UI, you should have a new target. It will select all the pods that were created by the deployment object. Here we have a single target with a single pod. Under configuration, you can also find a new job. PodMonitor object was converted to Prometheus job. You can notice that PodMonitor is much more concise, but you can still create Prometheus targets directly. It's important to understand. Let's test a few metrics exposed by the application. The first one is summary that returns P90 percentile. It also has a count metric. By itself, it's not very useful since it only goes up. You can switch to the graph and reduce the time interval to maybe 5 minutes. Usually, you apply rate functions to count metrics. In this case, we can get a number of HTTP requests per second that our app receives. Fake requests, of course. Alright, we're done with PodMonitor object. In the next example, we'll use a ServiceMonitor to do exactly the same. PodMonitor and ServiceMonitor are almost identical in how they function. They just select different objects. To test ServiceMonitor, let's delete PodMonitor first. In a few minutes, it should disappear from the targets section. If you go to configuration, you should also find the initial default config without any jobs. Now, ServiceMonitor, as the name implies, needs a service. Let's go ahead and create a new Kubernetes service for the application. Let's call it My App Prom and use only HTTP metrics port. Some people prefer to add monitoring port to the same service that we already created. Others prefer to create a dedicated service. For example, if your main service is of type of load balancer, of course you don't want to expose your metrics to the internet. It's up to you, but I would recommend creating a separate service to expose Prometheus metrics. Let's create that Prometheus service. When you create a service, Kubernetes will also create endpoint object. It's important to understand that in the ServiceMonitor object, we must select the endpoints object and not the service. However, they almost always have the same configuration. In the staging namespace, we have two services that created two endpoints objects. We're interested in the second one, My App Prom. Let's go ahead and describe that object. To select this endpoint, we need to use app equal to My App monitoring label and HTTP metrics port name. Alright, let's go ahead and create the ServiceMonitor object. The spec is very similar to PodMonitor. Since we created a staging namespace with Prometheus label, then we can also create the ServiceMonitor object in the staging namespace, and it will be discovered by our Prometheus. We have the same namespace selector. Now for the selector, we need to use service labels and not pod labels. I on purpose use different names. Here as well, we're not using the deployment named port. Instead, we're using the service name port that is translated to the endpoints port. /metrics path is a default which you can also omit. Next, we need to update Prometheus itself to discover service monitors. Again, we need similar selectors for the namespace and for the services. Most of the time, when you create a service or pod monitor and it's not showing up in the targets, it's the labels that you need to verify. Let's apply the changes to Prometheus first, then create a service monitor object. Now, the operator will automatically update Prometheus configuration, but to speed up this tutorial, I'll delete the pod and force restart with a new config. You can just wait for a few minutes for the reload. Every time when the pod goes down, you also need to rerun the port forward command, even if you use a service. If you refresh the Prometheus configuration page, you can also find a new service monitor job. Also, you should get a new target with a service monitor prefix. Next, I want to show you how to deploy Grafana using Helm chart and Terraform. Before you deploy it, I suggest that you add the Helm repo and pull default variables for the Helm chart. The current Helm version is 6.15.7. Now let's get the defaults for the Grafana. You can also output and save variables in the file. It will help you to configure Grafana deployment. I'll put it in Grafana values file. You can open that file and find all possible configurations that you want to update. To deploy this Helm chart with Terraform, first you need to declare the Helm provider. We'll use output variables from the EKS resource to initialize the provider and authenticate with EKS. Each time you run the Terraform, it will obtain a temporary token to access the EKS cluster. The next step is optional. Before you install the Helm chart, you can use Helm template resource to render all Kubernetes files that it will apply and store them locally. It can also help you to debug your deployment. You would use the same variables you want to override as in the Helm release itself. For example, I want to use a specific version, set the password, and enable persistence. Since it's a new provider, you need to initialize the Terraform. When you run apply, Terraform will save the rendered version to the local file system. You can open it and inspect the parameters you want to override in the deployment. If you set some variables that don't exist, Terraform will not show you any warnings. To actually apply the Helm chart, create a new file. Instead of Helm template, use Helm release resource with the same variables. Let's go ahead and install the Helm chart. You can use Helm list to get installed Helm charts. Also, you can check if Grafana pod is running. For example, if you forget to deploy CSI driver, it will get stuck in the pending state. Helm chart also creates a Grafana service that we can use in ingress or just port forward to localhost. It uses port 80 and not 3000. To log into Grafana, you can use default admin username and devops123 password if you use the same Terraform code. First of all, let's add a data source. Click on Prometheus icon. Then for the URL, use Prometheus operated service name created by the operator, and optionally you can add a monitoring namespace. The default port for Prometheus is 9090. Click Save and Test. Let's create a dashboard by using the same metrics exposed by the application. You can reduce the time interval to maybe 15 minutes since we don't have a lot of data for now. Let's call this dashboard traffic. For the metric, use the same tester duration seconds count and apply the rate function. In that way, we get a number of requests per second. You can also update the legend by using one of the metric labels, for example, path. Now, let me slightly customize the dashboard. Maybe update the legend, lines and colors. For the unit type, let's use requests per second (RPS). That's all for the dashboard. Based on the Prometheus, we get around 2 requests per second on the fake path. Another common use case for Prometheus operator is to monitor targets outside of Kubernetes. In this example, I'll use AWS specific target config, but you can easily update it to any other cloud, such as Azure or GCP. You can also just monitor static targets as well, following this principle. First, let's create a standalone EC2 instance. We need to create a security group and EC2 itself. I use user data script to install the node exporter when the virtual machine boots up. It's going to be external target for the Prometheus to monitor. We'll use this node exporter tag equal to true to dynamically discover EC2 instances with node exporters, which is much more convenient than manually updating IP addresses or host names. In the second part, we need to grant Prometheus access to AWS API to query EC2 tags. Since Prometheus deployed in Kubernetes, we need to use IAM roles for service accounts. All other public clouds can be configured in the same way. In AWS, you need to attach Amazon EC2 read-only access policy to the Prometheus. Let's create that IAM role and attach that policy. Now we need to get IAM Amazon resource name of that role. You can find it in AWS console or expose it using Terraform and output variables. To bind cloud-specific IAM roles with Kubernetes service accounts, we use annotations. This one is AWS specific. Now we can create additional scrape config as Kubernetes secret. In this case, it's AWS specific job, but can be really anything, even static targets. This job selects all EC2 instances in AWS with the node exporter tag equal to true. Finally, we need to add additional scrape config to Prometheus. You specify the Kubernetes secret name and a key that was used for the config. Let's apply them one by one. Service account, secret with additional Prometheus jobs, and update Prometheus configuration to include external Kubernetes targets. Now, just because I don't want to wait, I'll restart Prometheus again. If you refresh the targets page, you'll find a new node exporter job. That's all for this part, let's move on. The next topic is prop custom resource. Basically, it just uses black box exporter to query your targets. To use prop, we need to first deploy black box exporter to Kubernetes. It's a very simple deployment with a single replica and the latest version of the project. Then we need a service that we'll use as a prober URL. Go back to the terminal and deploy the exporter. then check if it's healthy. After we deploy the exporter, we can configure prop resource. We have the same Prometheus label. Mostly it's just a set of parameters that is converted to a black box exporter config. If you want to learn more about the prop, you need to look into how black box exporter works. In this example, I simply configure prop to query my personal website every 15 seconds. The response should be with a 200 status code. I think this is the simplest config, but it gives you idea of how to use it in the prop resource. Before creating it, we also need to update Prometheus resource. Similar to Pod and ServiceMonitor, we need to select the namespace and specific prop by its labels. Let's apply Prometheus changes and create a prop resource. Now, Prometheus should create a target based on that prop. In this case, it's antonputra.com/web. You can create alerts, for example, if the website is down for the users. There are a lot of metrics available that start with prop_prefix. For instance, prop HTTP status code gives you the last status code returned by the website. You may set up alert to send notification when the status code is not 200. The last topic that I want to cover in this tutorial is how to create Alertmanager and send alerts to Slack. First, let's create a Slack channel, give it a name alerts and make it private. Then go to api.slack.com and create a Slack app. Select create app from scratch. Let's call it Prometheus and I'll select my Slack workspace. The only thing we need to enable for Alertmanager integration is incoming webhooks. Let's enable it and select the Slack channel where we want to post alerts. I'll use alerts channel. If you want to test integration, you can copy curl command and run it in the terminal. Prometheus was able to post messages to the channel. The next step is to configure Alertmanager. You can use operator custom resource to create a config, but I really prefer to use a secret. I find it less confusing. It's a regular Alertmanager config with a single Slack notifications receiver. Here we also use alert label severity equal to warning label to send notifications to Slack. For example, you can create additional receiver for pager duty and send alerts there with a severity equal to critical. To configure Slack endpoint, we need to update Slack URL. That's all for the configuration. Next is a custom resource to deploy Alertmanager itself. Now the config. The name must be Alertmanager and the name of the Alertmanager, in this case main. Optionally, you can increase the number of replicas to 2 and it will form a highly available cluster. I'll keep it a single replica. That's all configuration needed to send alerts to Slack. Let's go ahead and apply it. Check the status of the Alertmanager. Prometheus operator also creates a service called Alertmanager operated. We'll use it later. Now, under Prometheus, we need to specify Alertmanager where we want to send notifications. Rules evaluated on the Prometheus side as any other query, and in case of the match, the message is sent to Alertmanager and based on the routing forwarded to Slack. Along with alerting config, we also need to create a similar selector for rules. Let's make this change. To speed up, I'll restart Prometheus. Next, let's create a rule that will be triggered if any Prometheus targets are down. In a few minutes, you'll find alert rule under alerts section in Prometheus. Green means all the targets are up. Now let's go ahead and stop the EC2 instance to trigger this alert. In a minute or so, you'll get a Slack message that my app EC2 instance is down and alert will transition to active state. If you start that EC2 instance, Slack will send another message that the alert was resolved and the instance is up now. I have a playlist with benchmarks that you may find interesting. Thank you for watching and I'll see you in the next video.